Assalamu alaikum dear students, how are you all? I hope you all will be fine. This is your maths teacher Ambish. This video lesson is for grade 6 from chapter number 12, 3-dimensional solids. And today we are going to solve our exercise 12.2. First of all, we have to know about the volume of 3-dimensional solids. We can calculate the area of a rectangular surface by its length and breadth, which is known as the 2-dimensional of a surface. But in case of the solid such as bricks, tea boxes and so on, we cannot calculate the area. These are 3-dimensional solids and occupy space. Hence, we use the term volume to measure them. So, we can define the volume as the amount of the space which an object occupies in a 3 dimensions is called its volume. I repeat the definition. The amount of the space which an object occupies in the 3 dimensions is called its volume. Unit of the volume. Volume is written in cubic unit. For example, the volume of a cube with side 1 centimeter will be as volume is equal to length into breadth into height. So, as we know that in a cube all the sides are equal, so 1 centimeter into 1 centimeter into 1 centimeter, that will be equal to 1 cubic centimeter. And the volume of a cube with the side 1 meter will be, so we will replace the centimeter by meter. Volume is equal to length into breadth into height, so that will be equal to 1 meter into 1 meter into 1 meter, that will be equal to 1 cubic meter. Now the volume of the cubes and cuboids. A box shaped object which has an equal length, breadth and height is called a cube. That is, length is equal to breadth is equal to height. So the volume of the cube is equal to length into breadth into height, but in the case of cube, as it is written, all the three sides are equal. So we can replace the breadth and height by the length. Length into length into length. It means length has a cube, or 3 times you will multiply the length to find the volume of a cube. Thus we can find the volume of a cube by the measurement of a single edge. To find the volume of an object, measurement of all dimensions should be in the same unit. This is very important point, that whenever you are finding the volume of cube or cuboid, just check that all the units should be equal. If they are not equal, make them equal and then do your further calculations. Okay, now cuboid. In a cuboid, length, breadth and height are 3 different measurements. So we need all the 3 dimensions to find the volume of a cuboid, that is equal to length into breadth into height. And now we are talking about the surface area of a cuboid. As we know that there are 6 surfaces of a cube as well as for a cuboid. So we have already learned the formula for finding the area of the surface. We use the same formula for finding the surface area of a cuboid. For the above figure, we can observe the 6 rectangular surfaces of a cuboid. Area of surface number 1, that is equal to length into breadth, and the area of surface number 2, that is equal to length into height. Area of surface number 3 is equal to length into breadth into height. Area of surface number 4 is equal to length into height. Area of surface number 5 is equal to length into breadth, and the area of surface number 6 is equal to breadth into height. So what we will do to find the surface area of a cuboid, we will add all these areas. By adding all these 6 surfaces, we can get the surface area of a cuboid. So that is equal to the area of surface number 1 plus the surface number 2 and 3, 4 and so on up to the surface area of number 6. And after that we will write the formulas of these surfaces as I have told you earlier. So we are observing over there that the length and breadth are 2 times over here, because the two faces are equal. So we can write them as 2 times. Similarly, the length and the height also occurring 2 times. So we can write it plus 2 length into height. And similarly, the breadth and the height, they are also occurring 2 times. So we can write 2 times breadth into height. And what we will do finally, we will take 2 as common from all the 3 values. I am taking as common. So inside we have length into breadth plus length into height plus breadth into height. And suppose the length is denoted by L, breadth is denoted by B, and the height is denoted by H. Then how we can write 2, and inside the bracket L into B plus L into H plus B into H. Okay, now we are going to find out the surface area of a cube. And as we know that in a cube all the sides are equal in the measure. Length, breadth and height, they all are equal. So we can easily replace the breadth and height by length. So in the formula, in the same formula as we have written for the cuboid, we will use, but in the place of breadth and height we will write the length. So 2 length into length plus length into length and plus length into length, and this will be equal to 3 times of length square, because when length is multiplying by length, that will be equal to length square, and they are 3 times. So we can write as 3. And now the 3 and 2, they are the digits and constant, so we can multiply them easily. 2 3s are 6 and length square. So this is the formula to finding the surface area of a cube with all the sides equal in the measure. Okay, now we are moving to our exercise 12.2. Question number 1 is there, that find the volume and the surface area of the following cubes, and I have just selected the part number 3, when the edge or a side of the cube is given to you, that is 2.5 meter. So the volume of the cube is equal to length into breadth into height, but as we know that in the cube length and breadth and height all are equal, so we can replace the breadth and height with the length. So the final formula is length into length into length. So 2.5 meter into 2.5 meter into 2.5 meter, and after all the multiplication we will have 15.625 meter cube, because the meter is multiplying 3 times, so it will be meter cube. Whatever is the unit given to you, you will write as a cubic form. Okay, now the surface area of a cube, that will be equal to 6 and length square. 6 is the constant and the length is 2.5, take a square. After the square we will have 6.25 into 6, and after final multiplication we have 37.5 meter square. This is the surface area of a cube. Okay, now we are moving to our question number 2. Find the volume and the surface area of the following cuboids. And in this question I have selected the part number 3, in which the length is given to you 75 centimeter, breadth is given to you 50 centimeter, and the height is given to you 1 meter. And we are observing over there that the two units are same, centimeter and centimeter, but the third unit is not same. So first of all we will change the centimeter into meter, as we know that 1 meter is equal to 100 centimeter. So the height become 100 centimeter. And now all the units are same, all are in centimeter, we can easily find out the volume as well as the surface area. Volume of the cuboid is equal to length into breadth into height, 75 centimeter into 50 centimeter into 100 centimeter. After all the multiplication we will have 375,000 centimeter cube. Yes, after the multiplication we have 375,000 and centimeter cube, as I told you that the unit for the volume is cubic unit. Now we are going to find out the surface area of the cuboid as we have discussed earlier the formula. So I am writing over here 2 into L into B, length into breadth, then plus L into H means length into height, and plus B into H means breadth into height. So after substituting all these values, we are observing over there 75 centimeter into 50, and then plus 75 into 100 centimeter, and then plus 50 into 100 centimeter. After the multiplication, we will have 3750 centimeter square, because we are multiplying 2 times centimeter, so it will be a square unit. And 75 100, or we can read it as 7500 centimeter square and 5000 centimeter square. First of all, we will add all these values, and that will be equal to 16250 centimeter square, and then we will multiply by 2. After final calculation, we will have 32,500 centimeter square. This is the surface area of a given cuboid. And this is the end of our exercise. I hope you will understand this exercise very nicely. Thank you.